Alright class, let's try to get the basics of free fall done today. So essentially, here's what you need to remember. If things are in free fall, number one, the acceleration it's experiencing is negative 10 meters per second squared, regardless. It has to be negative 10 meters per second squared if it's in free fall. There is no option. It doesn't matter how fast it's going. It doesn't matter if it's just dropped from rest, or if it's thrown down at 10 meters per second, or thrown down at 1,000 meters per second, or thrown up at 1,000 meters per second. It will still have an acceleration of negative 10 meters per second squared. So that's the first and most important thing. Okay? The second thing you need to know is that this negative 10 meters per second, what that means is that it's accelerating at 10 meters per second every second. So at the end of 4 seconds, it would be going 40 meters per second, or rather negative 40 meters per second. So your formulas from the previous stuff still hold. So your three big formulas, sorry, let me write them down. A is equal to VF minus VI over T. D is equal to 1/2 AT squared plus VIT. And VF squared equals VI squared plus 2AD. All these problems still hold. They're still all good, but you just know for a fact that negative 10 meters per second squared is your acceleration. Just some other key terms to know. If it says from rest, that means that, from rest or dropped, you know that the initial velocity has to be 0. Okay. This is just really basic stuff on when things are falling. If it's not from rest, so if you throw it down at initial velocity of say 10 meters per second, that's all good. You just need to make sure that you fill in initial velocity as 10 meters per second. It could be 0 if it says it's from rest or if it's dropped. But if it doesn't say that and it says I throw it down at 10 meters per second, you need to make sure you plug it in. The other important thing is to make sure you keep your directionality right. So if you throw it down at 10 meters per second, your initial velocity would be negative 10 meters per second. Okay? And so that way you know that it's going down. Remember, the negative only indicates the direction that it's going in. Alright, let's look at what happens if I throw a ball up. Let's say I throw a ball up at 5 meters per second. Okay? That means the initial velocity is equal to 5 meters per second. So let's look at what happens throughout the course of this. If I throw this ball up at 5 meters per second, then it's going to undergo an acceleration of negative 10 meters per second squared. So you notice here how I have a negative for my acceleration and a positive for my initial velocity. That's perfectly legal. All that means is that it's going to slow down as it goes up. So whenever it reaches the top of the path, up here at the top, its velocity is equal to 0. It's important for you to remember this, because what this can mean is that the final velocity at the top can be 0, or the initial velocity for the way down can be 0. All right, depending on how you look at it, right? So if I wanted to figure out the time in the air, I could say, all right, VI is equal to 5 meters per second, VF is 0, and I could solve for time, because A is equal to negative 10 meters per second. So here we go. We could do this real quickly. A equals VF minus VI over T. So we'd get negative 10 equals 0 minus 5 over T, and T would equal 0.5 seconds. Okay, so there you go. That's how you would solve for it if you count the top as the final velocity. What about counting it as the initial velocity? When would that come in handy? Well, what if I gave you the time, but you didn't necessarily know how high it had been dropped from yet? Well, in that case, or how high it had gone up, well, it's a lot easier to figure out how high it had gone up by figuring out how far it fell. Why is it easier to figure out how far it fell? Well, if you figure out how far it fell, 1/2 AT squared plus VIT, if you're finding how long it fell, what's the initial velocity? Well, if you're finding how far it fell, the initial velocity is at the top, so it's 0 and it cancels that term out. So it makes it a lot easier for you to figure out how far it fell if you use that. It also makes it easier to figure out how long it took to go up. If you think about the fact that the time up is equal to the time down. So time up has to equal the time down. Alright, so it's much easier to figure out the distance it falls if we use the initial velocity on the way down is equal to 0. Alright, so just some things to remember about this when it's going up. Alright, the last thing is that when it comes back down here, it will be going -5 meters per second. So some basics to remember whenever you have a ball being thrown up. Number one, time up equals time down. That's important to remember. So if I throw it up and it takes 2 seconds to go up, how long was it in the air? It was in the air for 2 seconds. How long did it take to get to the top? 1 second. Number two, distance up is equal to the distance down. Right? That makes sense because it's going to fall the same distance it went up. Distance up equals distance down. 3, initial velocity will equal, final velocity will equal the negative of the initial velocity. And then 4, the top velocity at the top equals 0. And the last thing is keep up with signs. They'll come in handy, okay? Make sure you keep up with your signs. Remember that if it's going up, it's positive. If it's going down, it's a negative, okay? So don't forget that. Alright, so that's basics on free fall. Alright, I hope that helps y'all. If you have any questions, feel free to let me know.